Hi, I'm Sammy Sadler, an applications engineer here at Instron, and in this video we're going to talk about the main differences between the most commonly used tensile grips, specifically the differences and advantages of manual versus powered and side action versus wedge. The basic purpose of a tensile grip is to hold your specimen firmly in place during a test without influencing the results. Two things that influence the results negatively are slippage and jaw breaks. Slippage occurs when a grip isn't holding onto the specimen with enough force and the specimen slips out of the jaw faces. Jaw breaks occur when the grips are applying too much force and the material breaks within the faces. These are two main factors we look to avoid during materials testing. Going a step further, the right grip should also take into account throughput requirements, repeatability, and compatibility with other equipment such as extensometers. Other factors you must consider are power requirements and operator safety and comfort. There are a lot of tensile grip options out there, so we're just going to focus our discussion on the major differentiators, including the actuating mechanisms and the style of grip, specifically wedge versus side action. When we talk about manual versus powered grips, this refers to how the jaw faces are opened and closed. On a manual grip, there is generally a mechanism that the operator turns or twists to open and close the jaw faces. This means that it's up to the operator to use the correct amount of torque to keep the specimen secured without being too tight to cause damage or too loose to cause slippage. On the other hand, opening and closing jaw faces on a powered grip is usually as simple as flipping a switch. Power generally comes from either compressed air for pneumatic grips or hydraulic fluid for hydraulic grips. Clamping force is a setting and is usually controllable within a given range. One of the primary benefits of a powered grip is that it maintains a consistent clamping force on your specimen throughout the test, whereas a manual grip, like a screw side action, the jaw faces do not move during the test, and as a result, the clamping force on the specimen may decrease as it's pulled. In most instances, powered grips are preferred and recommended. They're more efficient for better throughput, and they add a layer of control and consistency by giving you the ability to set and maintain the clamping force. That being said, there are situations where a manual grip may be better suited. For instance, some delicate specimens can be easily damaged by powered grips, even at the lowest pressure settings. Additionally, we may encounter thicker specimens which require a wider opening between the jaw faces. Manual grips tend to have more options for these types of samples. In some cases, your gripping points may not be perfectly aligned top to bottom, such as lap shear or component testing. In these situations, you'll need a grip that can be offset like a screw side action. Some powered grips do have this capability, but it tends to be more widely available on manual grips. Sometimes the choice of manual versus powered comes down to which services your lab has access to. Pneumatic grips require access to compressed air, which can be integrated into your system using Instron Smart Close Air Kit, or by using an external air compressor. Hydraulic grips may not be preferred in certain environments such as clean rooms, where hydraulic fluids are not ideal. Another consideration is footprint, because any external hydraulic pump or air compressor will require additional floor space. Now that we've covered our options for actuating the grips, let's talk about closing styles, wedge versus side action. A wedge grip works the same way it sounds. The grip body and jaw faces form a wedge so that when the grip is actuated, the grip body forces the jaw faces together. One of the advantages of this design is that a specimen with good engagement will continue to pull the jaw faces further into the wedge during the test, helping to maintain the clamping force and prevent slippage. There are two different styles of wedge grips, moving body and moving face. This refers to the movement of the grip when you open and close the jaw faces. With moving body, which is the most common, the body of the grips move up or down while the jaw faces stay in place, meaning the clamping force is applied to the specimen from the sides. With moving face, the faces move up or down while the grip body stays in place. This movement into the gauge length can introduce a compressive force on the specimen, meaning they should only be used to test strong materials such as rebar that won't be adversely affected by this type of force. Now if we look at a side action grip, you can see these are fairly straightforward. The clamping force is directed at the specimen from the sides. Both grip styles are very versatile, and sometimes it just comes down to user preference. But here are some differentiators. If you work with delicate specimens, we'll generally recommend a side action grip, since there are more options at very low forces. Another deciding factor is specimen shape and geometry. Side action and wedge grips are well suited for flat specimens, but wedge grips are preferred for rounds because they provide better jaw face engagement. Wider specimens require larger jaw faces, but the jaw face width on a wedge grip is fixed to the size of the grip, meaning that you need a different grip to accommodate the extra size. The open design of a side action grip means they have greater flexibility to accommodate a wider range of specimen dimensions. For specimens that don't support themselves, such as thin films or foils, we recommend side action grips. These types of specimens require space above the jaw faces to properly load, which wedge grips don't have. Side action grips are a bit more flexible in terms of the types of tests they can perform. This includes tensile, compression, torsion, and offset or component testing, whereas wedge grips should only be used for tensile and compression. From a maintenance standpoint, wedge grips require grease in order to operate. So, if your testing produces a lot of debris, you may need to clean and re-grease your grips more often. If you change out your load string frequently, you may want to consider a set of grips that allows for piggybacking. Some of the higher force capacity grips can weigh hundreds of pounds, making it very inconvenient to change out. Piggybacking allows these grips to remain on the load string while other fixtures are used. And lastly, this discussion wouldn't be complete without mentioning the importance of jaw faces. This is arguably just as important as picking out the right type of grip. There are a wide range of sizes and surface finishes to fit nearly every type of specimen. These include rubber-coated, serrated, smooth, wave profile, and other more niche types. As you can see, there's a lot to consider when picking a tensile grip. While this video will hopefully provide some general insight into your options, we always recommend connecting with your local sales engineer to discuss your specific application. For more information, visit our website or contact us with any questions. Thanks for watching.